Alright, so, something that I've been wondering about. I've actually wondered about this for years. I just didn't really have a way of saying it. So what if we took something like this, right? So the the separated out part of taking a limit that just approximates our value, right? So we're getting as close as we can to the value without actually getting the value, right? This is the closest possible number to, you know, whatever I have in here, 5 or 17 or square root of 2, something like that, right? So, what if something like that applied to an irrational like pi? What if that came out to be rational? Or, some, maybe not the one right next to it, but some finite number of them away from it, which would still be impossibly close to it, right? Because even if you did, an infinite number of these, right, you're still so impossibly close to the value that you're looking at that no matter how far you zoomed in, you couldn't see it. You couldn't see the difference, right? Because of how this works. But for instance, we know that there's going to be numbers right next to each other which are irrational and rational, right? Anything that's right up next to a rational number is going to be irrational itself. So this is definitely going to be irrational. But what if there's some sort of pattern, right? So like, what if we did like, say, prime steps away, and they're all rational? That would be interesting. Like, who knows? This is a completely unexplored space. I don't know how to explore this, but I think it's an interesting sort of thing to look at, and this thought has absolutely occurred to me, since I want to say at least middle school, fifth or sixth grade or so. Definitely, I remember trying to talk about it in high school while taking calculus because it seemed very, very relevant to what was happening. We're talking about infinitesimals here in the first place, right? That's usually how calculus is presented. Although the way that I independently invented calculus about a year before I first saw any calculus, the way that I did it didn't actually approach it that way at all. I approached it syntactically, just looking at the formal structure of equations. I was able to actually suss out a completely a class of equations that we weren't shown in until the very, very end of the calculus class in high school. And that was actually when I realized that, oh shit, that's what I did. I actually discovered a an avenue into calculus on my own a couple of years before that. Um, and what it was, like the way that it was presented, it was just like a bonus question on the test. And I was the only one that got it right. And the instructor was like, how'd you get that right? Because you didn't show any work. And I'm like, I don't actually know how to show the work. But I it's just a syntactic property of this class because it was involving circles. So what I did, and this was so it was like growing something like the surface area of a sphere or something, right? In n dimensions, some shit like that. So it was asking about like how do you find something about like a four dimensional circle or something like that. And I was just like, yeah, I know what this is. And the way that I had figured it out is I just considered a point, a line, a circle, and a sphere, and looking at those equations was like, oh, well, I guess in 4 dimensions it's going to act this way based on the way these equations are changing as we add dimensions. It's going to do this. And I had a generalized formula for that. And I just memorized it because it's not really that hard. I don't remember it anymore, but it's not that fucking complicated. I'll look it up for 2 seconds and there it is again. Anyway, like, it was beat into our heads that, yeah, calculus is about infinitesimals and shit. So it was like, okay, so there's got to be something, right next to 4. There's got to be a closest value to 4 that isn't 4. There's got to be something that is the absolute closest to it that isn't it. And it's not going to be rational, for damn sure. It's going to be irrational. And it's not going to be like 3.9 repeating, right? Because you're going to have to break one of those 9s somewhere. But at any point you break it, you could have broken it somewhere else, right? You could have broken it further down the line. So you could always get closer. Once you decide to turn a 9 into an 8, you could get closer than that. Right. So it's a completely, like, how do you approach this? There must be something there. But how could you possibly get to it? Right. Yeah. So, like, this sort of question has been present for a very long time for me. But since we know for a fact that you're going to have rationals right next to irrationals, you can now like ask the question, well, how likely is it, given an irrational, that something right next to it, or that we can actually reach in a finite number of steps, is going to be rational? And are there patterns to this? So, yeah, I don't know how to do that at all, but kind of an interesting avenue of future thought on this sort of issue.